Welcome to homework.
Okay, we have a list of functional group names. Aldehyde, ketone, carboxylic acid, ester, secondary amine, terminal alkyne, nitrile, primary amine, internal symmetrical alkyne, and a secondary alcohol. We also have various functional groups, which I will draw in bond line format. Right, so beginning with A, we have a carboxylic acid, which also bears a terminal double bond. B, we have an ester, a methyl ester, with a phenyl ring. C, we have an alkyne that is in the middle of a 1, 2, 3, 4, 5, 6 carbon chain. D, we have a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain with an alkene on the end. And we also have a bromine on carbon 3. And we have a 1, 2, we have a chloro on carbon 7. And a hydroxyl on carbon 1, 2, 3, 4. Okay, E. We have nitrogen triply bound to carbon, which has a methyl group. F, we have nitrogen bound to a phenyl ring, or aniline as the molecule is known. Let's move over here for G. We have a 1, 2, 3, 4, 5, 6, 7 carbon chain with an alkyne on the end. And on carbon 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, sorry, this is a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. And on carbon 6, we have an ethyl group. G, H, we have an aldehyde, a methyl, and a carbon with a double bond to oxygen and a hydrogen. H, I, we have an, methyl, methylene, carbon bound to oxygen. This is a ketone with a methyl on one side and an ethyl on the other. And then J. We have a methyl connected to a nitrogen, which has a hydrogen, and also has an isopropyl attached. Okay, now we can start to match each functional group with a name, with a representative compound. So where can we find an aldehyde? That's a carbon that has a double bond to oxygen and a single bond to hydrogen. That's right here. That's H. Let's go ahead and use capital letters. I don't know why I switched to lowercase partway through, but it should be capital. Okay, as for a ketone, we need a carbon with double bond to oxygen and carbons on either side. That is clearly I. Carboxylic acid, we need a carbon with a double bond to oxygen and a single bond to a hydroxyl. That is A. For an ester, we need a carbon with a double bond to oxygen and then a single bond to an oxygen, which is bound to more carbon. That's right here. Okay, so that's B. A secondary amine is a nitrogen, which has two bonds to carbon and a single bond to a hydrogen, and that's right here, right? Carbon, carbon, hydrogen. So that's J. Terminal alkyne is simply a triple bond on the end of a carbon chain. That's G right here. A nitrile is a carbon triply bound to nitrogen, which we see in E. A primary amine is a nitrogen with one bond to carbon and two bonds to hydrogen, which we see here with F, example F. Internal symmetric alkyne is a triple bond that is in the middle of a carbon chain, such that the length of the carbon chain on either side of the alkyne is equal, meaning triple bond with a 1,2 carbon chain and a 1,2 carbon chain on either side. That is an internal symmetric alkyne. And finally, a secondary alcohol is a carbon chain, which there is a carbon with a bond to carbon, another bond to carbon, and a bond to a hydroxyl. Carbon, carbon, hydroxyl. That's a secondary alcohol. And so that is D.